Distance formula. How to use the distance formula. What is it? The distance formula is used to find the distance between 2 points. Y can help you figure out the distance to navigate while sailing. Interesting fact, giant pandas eat as much as 10 kilograms or 22 pounds of bamboo a day. Now here are the examples we're going to be discussing in today's video. Let's take a closer look at example 1. Now let's read the steps. Step 1, use the formula. Step 2, follow order of operations. Now let's read the question. Segment AB has the endpoints negative 3, 2, and 3, 2. Find the length of segment AB. Since segment AB has been plotted already, all we have to do is write down the distance formula. And that formula is the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. We have all those x2s, x1s, y1s, y2s. Let's go ahead and label our points so we're not confused. And we're going to label the first point, negative 3, 2, as x1, y1. Now we're going to label the second point, 3, 2, as x2, y2. Can we flip-flop the labeling? Yes, we can. We will get the same result. But let's continue by substituting 3 for x2, since that's the first variable in the formula. Now let's go ahead and substitute negative 3 for x1, and 2 for y2, and 2 for y1. Now we have the square root of 3 minus negative 3 in parentheses squared plus 2 minus 2 in parentheses squared. Let's continue with the order of operations by simplifying inside the parentheses by making the double negatives a positive. Now we have 3 plus 3 in the first parentheses and 2 minus 2 in the second parentheses. So now overall we have the square root of 3 plus 3 in parentheses squared plus 2 minus 2 in parentheses squared. Let's continue with the order of operations, and 3 plus 3 gives us 6, and 2 minus 2 gives us 0. So now we have the square root over 6 squared plus 0 squared. So now let's square these numbers. 6 squared is 36, and 0 squared is 0. So now we have the square root over 36 plus 0. Well, let's add those two numbers, and the result is 36, because 36 plus 0 is 36. And now we have the square root of 36, and the result of that is 6. Can't forget our unit since we're talking about distance, so our final answer is 6 units. Since it didn't specify a unit, like centimeters or meters, we use the word units. Now, let's use the graph to show you why this is the case. Luckily, segment AB is horizontal. So in the end, we could just count the spaces in between point A and point E, and we should get the same answer. So let's go ahead and get started. 1, 2, 3, 4, 5, and 6. So we have the same answer. We did it correct. Now let's take a look at example 2. Now let's read the question. Segment AB has the endpoints negative 2, 4, and negative 2, negative 3. Find the length of segment AB. Since segment AB has already been plotted for us and we're finding the distance, let's go ahead and write down the distance formula. And that formula is the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Since we have some x2s, x1s, y2s, y1, let's go ahead and label our points. We're going to label our first point, negative 2, 4, as x1, y1. And we're going to label our second point, negative 2, negative 3, as x2, y2. Once again, can you flip-flop the labeling? Yes, you can. You're still going to get the same answer. But now we're going to substitute negative 2 for x2, because x2 is written first in the formula. And now we're going to substitute negative 2 for x1. And now we're going to substitute negative 3 for y2. And lastly, 4 for y1. And now we have the square root of negative 2 minus negative 2 in parentheses squared plus negative 3 minus 4 in parentheses squared. So we're going to simplify, inside the parentheses by making our double negatives a positive. And so we have changed the first parentheses because that had double negatives. And now we have the square root of negative 2 plus 2 in parentheses squared plus negative 3 minus 4 in parentheses squared. Let's continue by simplifying what's inside the parentheses. And now we have 0 squared plus negative 7 squared, because negative 2 plus 2 is 0 and negative 3 minus 4 is negative 7. Now we have the square root of 0 squared plus the parentheses of negative 7 squared. Let's go ahead and square those numbers. 0 squared is 0 and the parentheses of negative 7 squared is 49. And now we have the square root of 0 plus 49. And 0 plus 49 is 49. So now we have the square root of 49, and the result of that is 7. Can't forget our units. Since we're talking about distance and they didn't give us a measurement in the question, our answer for this question is 7 units. Now, let's use a graph to show you why this is the case. So we're going to go ahead and start counting from B to A. So we have 1, 2, 3, 4, 5, 6, and 7. So we used the graph to show you that the answer is also 7 units. Now, luckily for us, this line was vertical and the previous one was horizontal. So if you have those two type of lines, you can just go ahead and use the graph and count instead of using the distance formula. Or if you want to use the distance formula, you still can, just to verify. Now, let's take a look at example 3. Now let's read the question. Segment AB has the endpoints negative 4, negative 3, and 4, 3. Find the length of segment AB. Since segment AB has already been plotted for us, now our first step is to go ahead and write down the distance formula. Now in this case, since our line is diagonal and not vertical and not horizontal, we have to use the distance formula. And now, since we have x2s, x1s, y1s, y2s, we're going to go ahead and label our points so that we're not confused. We're going to label the first point, negative 4, negative 3, as x1, y1, and we're going to label our second point, 4, 3, as x2, y2. Now we've labeled our points, let's go ahead and substitute our numbers into the formula. And since x2 is first, we're going to substitute 4 for x2. And now we're going to substitute negative 4 for x1, 3 for y2, and negative 3 for y1. And now we have the square root of 4 minus negative 4 in parentheses squared plus 3 minus negative 3 in parentheses squared. Let's continue by doing the order of operations, and we're going to simplify in the parentheses. First, getting rid of our double negatives and making them a positive. So we're going to make the first parentheses 4 plus 4, and we're going to make the second parentheses 3 plus 3. And now we have the square root of 4 plus 4 in parentheses squared plus 3 plus 3 in parentheses squared. So let's continue by following the order of operations, and we're going to add inside the parentheses. 4 plus 4 is 8, 3 plus 3 is 6, and now we have the square root of 8 squared plus 6 squared. Let's continue with squaring the numbers. So we're going to square 8, and that is 64, and 6 squared is 36. So now we have the square root of 64 plus 36. Let's add those two numbers, and the result of that is 100. So now we have the square root of 100, and the result of that is 10. We can't forget our units since we're talking about distance, and our answer is 10 units since there was no unit specified in the question. Now, let's use the graph to show you why this is the case. Let's start by drawing a dotted line from point A to underneath point B, and let's continue by drawing another dotted line from the end of that dotted line to point B. As we can see, we have created a right triangle where segment AB is the hypotenuse and the two dotted lines are our legs. Now, let's find these measurements of these legs. First, by counting at point A. So we have 1, 2, 3, 4, 5, 6, 7, and 8. Let's continue with the other leg. 1, 2, 3, 4, 5, and 6. So we found the measurements of these legs, 8 units and 6 units. Now if we take a look on the left side of the screen with the distance formula, in the middle we have the square root over 8 squared plus 6 squared. Same measurements. So we can use the graph and specifically the Pythagorean theorem to find the segment AB as well. Now let's take a look at example 4. Now let's read the question. Segment AB has the endpoints -2, 4, and 3, -1. Find the length of segment AB. Luckily for us, segment AB has already been plotted on the graph. And since we're finding the distance, let's go ahead and write down that distance formula. And the formula is the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Since we have x1s, y1s, y2, and x2, let's go ahead and label our points so we're not confused. So we're going to label the first point -2, 4 as x1, y1. We're going to label our second point 3, -1 as x2, y2. Once again, can we flip-flop the labeling? Yes, we can. We will get the same answer. But let's go ahead and substitute 3 for x2, since x2 is written first. And now we can substitute -2 for x1. We can substitute -1 for y2. And we can substitute 4 for y1. And now we have the square root of 3 minus -2 in parentheses squared plus -1 minus 4 in parentheses squared. Let's follow the order of operations so we can simplify this answer. The first one that we're going to do is get rid of our double negatives by making them a positive. And so now we have 3 plus 2 in the first parentheses, and we still have -1 minus 4 in the second parentheses. And now we have the square root of 3 plus 2 in parentheses squared plus -1 minus 4 in parentheses squared. So let's add or subtract the numbers in the parentheses, and we get 5 because 3 plus 2 is 5, and -1 minus 4 is -5. And now we have the square root of 5 squared plus, in parentheses, -5 squared. Now let's square those numbers. 5 squared is 25, and the parentheses of -5 squared is also 25. Now we have the square root of 25 plus 25, and the result of 25 plus 25 is 50. Now we have the square root of 50. 50 is not a square number, but we can rewrite it so that it does have one. Now we're going to change the square root of 50 to the square root of 25 times the square root of 2. And we can do that because 25 times 2 is 50. And the square root of 25 is 5. And now we have 5 square root of 2. And this is our answer. Since we can't go any further, all we have to do is add our units. And now we have 5 square root of 2 units as our final answer. Now, let's show you why this is the case using the graph. We're going to draw a dotted line from point B to underneath point A, and now we're going to continue by drawing another dotted line from the end of that dotted line to point A. As we can see, we have formed a right triangle where the hypotenuse is segment AB, and the 2 dotted lines are the legs. Now, let's find the measurements for these 2 legs by counting from the right angle to point B. So we have 1, 2, 3, 4, and 5. Now let's count to point A. So we have 1, 2, 3, 4, and 5. Both legs are 5 units long. Now if we take a look at the distance formula in the middle, where we have square root of 5 squared plus the parentheses of -5 squared. These numbers are basically the same, just that one of them is a negative number. Remember, distance can't be negative. That is why we square it, so we get rid of that negative number. And so we have shown that we can also use the Pythagorean theorem to find the distance of segment AB. Now, it is your turn. So go ahead and pause the video so you can take your time to answer this question, and I will show you the result in 3, 2, and 1. If you got it right, congratulations. If not, there's always tomorrow.